Last class, we were introduced to the equation 2 to the x equals 12. We knew that 2 cubed is 8. We knew that 2 to the 4th was 16. We thought that 2 to the 3.5 must equal 12. No, that can't be because the function's increasing at an increasing rate. We thought it's got to be a little bit bigger than 3.5. We thought 3.75. Wrong. We thought 3.6666. Wrong. We thought we had a hole in a graph. No. What we found is that the answer was a logarithmic number, an irrational number that we call logarithmic. And we understand that logarithms are inverses of exponents. Okay? Now, this is where we stopped last class. We were like, this number we can't find. Well, today we will still be looking at logarithms. Now, of course, we know that this answer is just 3. You look at 2 to the x equals 8. You're like, oh, the power has to be 3. But the way we're going to be approached with this type of question is I'm going to say, hey, the log base 2 of 8. What does that equal? And you are going to get a numerical answer. Last class, we were okay with leaving our log answers because the questions we were asked did not have nice answers to them. But this class, we will be asked to find this logarithmic value. And what I'm going to show you are multiple ways to figure out that this is 3. But one of the best ways to have this in your brain, that this is 3, is to be able to go back to this statement. 2 to the x equals 8. Let's say I didn't know what the log base 2 of 8 was. Let's say I didn't know that that was 3. And this was the question that I had. Well, you could always say, I know that an exponent undoes a log. We can go and say 2 to what power is 8? And then we could say, oh, this is an equivalent statement to this. This is 3. So the log base 2 of 8 is 3. Now, we do that enough, and it gets into our brain that when I give you the log of a base of a number, that the answer is the exponent. And you can have that memorized, and it might stay in your short-term memory bank. Maybe it moves to your long-term memory bank, and that would be great if that was the case. But if it doesn't, if it all of a sudden leaves, and you get to the point in a future class where you're like, I have no idea what logs are, at least have the basic fact that logs are inverses of exponents kept in your brain. So you can always say, hey, 4 to what power is 16? 16 equals 4 to what power? 2. Square roots are not the inverses of exponents. You understand the following, Woods, that if I took both sides to the 1/2 power, would that undo x? What would you get if you took both sides to the 1/2 power? Well, you'd get 2 to the 1/2 x equals the square root of 8. So no, square roots, cube roots undo squares and cubes. Yes, exactly. Yes. Yeah, but that's not an exponential variable. That's an x to a numerical exponent. It's 2 different situations. 3 to the x and x cubed are very much different functions. You got that one? So how do you get rid of the 3 here? I'd use a 1/3. How do you get rid of the 3 here? I would use a log base 3. Cool? Yes. To get rid of like a base, numerical base, you have to use a logarithm. To get rid of a numerical exponent, use a root. Cool? All right, cool. Now, We're not going to spend all this time redoing things over and over and over again. We understand 6 squared is 36. We understand that if you took the log base 6 of both sides, the log base 6 of 6 squared is 2. 2 equals the log base 6 of 36. Or, more importantly, the log base 6 of 6 squared is 2. This is a very, very important statement right here. If logs undo bases of exponents, then the log base whatever of that thing to a number will just be the number. This is how, cross this off, we can just let go of it. This is how if I say, hey, graph log base 4 of x, just graph it right away. Now, last class I would have said, understand what 4 to the x looks like. Understand that log base 4 is the inverse of 4 to the x. Look at points on 4 to the x, flip-flop them, and you'll get points on the log base 4. But now, I understand easy x values to plug in there. Tell me, what is an easy x value to plug in the log base 4? 1's an easy x value. Sure. 2 is not an easy x value. I don't know what the log base 4 of 2 is easily. Like, yes, we can get it. 4 is a good one. The log base 4 of 4 to the first power is 1. Okay, so let's write down points on the log base 4. I have the point 4, 1. Now, I can plug in 16, but watch what I'm going to do. The log base 4 of 4 squared must be 2. 4 squared is 16. I know I have the point 16, 2, or 4 squared, 2. Because what is an easy value to find the logarithm of? Yeah, because I just like, it's the same thing. It's the same thing. Why do you say 2 doesn't work? Because it does work. But you know what I'm going to write? The log base 4 of 4 to the 1/2 is a half. Now, 4 to the 1/2 is a half. If you have a power of 4, you can easily plug it in. Sorry, this is 2, 1/2. If you have a power of 4, you can easily plug it into the log base 4. And this is what we're kind of figuring out today, is that logs, you can find numerical values of logs if you're understanding that the base to the power, you're just going to get the power. The answer to a log is an exponent. Some things people just kind of understand. Some people don't just understand. But you can always say, hey, 4 cubed. The log base 4 of 4 cubed is 3. 4 cubed is 64. I know the log base 4 of x has the point 64, 3. Okay? And we could rewrite these over and over again, but they're not really important. They're just kind of stating the obvious. Hey, the log base 10 of 1/10 is -1 because the log base 10 of 10 to the -1st is -1. This is 121 to the 1/2 power. The log base 1/2, base 121 is taken. We get 1/2 equals the log base 121 of 11. Why? Because 11 can be written as 121 to the 1/2. An answer to a logarithm is the exponent because logarithms and exponents are inverse. If I have it in this form, now on your homework and on the next page, you're just going to be asked, what is the log base 3 of 81? Here are the multiple ways you could figure out what the log base 3 of 81 is. You could either start with I don't know. I'm not sure what it is. But I know logs and exponents are inverses of each other. You could rewrite this and say 81 equals 3 to something. I don't know. 3, 9, 27. Oh, 81, the answer is 4. Boom, there's your answer. That's one way to do it. Here's another way to do it. You don't know what the log base 3 of 81 is, but you know the log base 3 of 3 to a power is the power, because you know like logs and exponents undo each other. Well, I know that 3 to the 4th is 81. The log base 3 and the 3 will fight to the death. They'll lose. 4 wins. There's another way to get the answer. Or what most of you will do, maybe because you remember this from the past, and hopefully it'll stay with you, is you say the answer to the log is an exponent. And that's fine. I just hope it sticks with you. 3 to the 4th is 81, and you'll just write the answer 4. I don't care how you do it, just get the right answer. And if you don't know what the right answer is, maybe try a different approach. Why is the log of any base of 1 equal to 0? Please explain to me why the log of any base of 1 is 0. Tell your neighbors. Tell everybody. Why? So, like, this is the key, guys. Some people are looking at this and it's still confusing to you, and especially I'm going to put a letter in there, and you're like, oh, I have no idea what's going on. But if you know that log that anything to the 0 power is 1, this is so important. The log base 4 of 1 is 0 because 1 can be written as 4 to the 0. Cool? The other statements are just like, hey, rewrite. But let's get to some actual questions, okay? And then we're going to do some of the homework. And there are some really good, challenging questions on the homework that a lot of you are going to get stumped by. Okay? So, we will be fine to start. But I bet you, no, false. Sit down, do some of these problems, and show me you can do it. No, you didn't. And then we can go. Yeah, hi. Good to see you. How are things? Are you getting into schools already? All right, congrats. I'm glad. You know what people do when they have to use the restroom in the middle of a lesson? It's usually because they have to use the restroom. But sometimes, it's sometimes because they do not want to engage mentally in what is going on. I'm not saying that's you. I'm saying usually it's you have to go to the bathroom. But sometimes it's called a mental cop-out. A good old, hey, can I use the restroom? It's like, this is the first question I want you to do, and now you want to use the restroom? Maybe we're mentally tired more than physically needing to go to the bathroom. Great, that's one way to do it. What is the answer to this logarithm? There are multiple ways to get the answer. We're going to do them all. Good. Now, here's what I see. I see some people just writing 2. Great, great. If you could just be like, I know, I got this. I got this. The answer's 2. Great. I see some people being like, I'm not sure. I'm going to call this X. I'm going to take 7 to the power of both sides and rewrite this question. Now, what I would do is keep 49 where it is. It's not bothering anybody, and have X where it is. It's not bothering anybody as the power of 7. And I just rewrote the question that makes sense to me, and I see that the answer is 2. So maybe we get that value 2 the other way. And then I saw somebody out there say, hey, this 49 can be written as 7 squared, and the log base 7 of 7 squared is just 2 because logs and bases of exponents undo each other. Pick a way that works for you, but be ready, if your way doesn't work, to use another method. Okay. Good. Go. Thank you. You got to sign out, though. Is 0 to the power 0, 1? 0 to the power 0 is actually undefined. What's the inverse of a root? A square or a cube. The numerical power. Some of you can look at this and be like, oh, logs are just like the values of logs are exponents and you put -3. Great. Some of you cannot get that. And some of you will need to rewrite this as 2 to the power, making sure you rewrite it carefully. 2 to some power is an 8. And then you can get the answer -3. Some of you will be able to say 2 to some power is 1/8. I know 2 cubed is 8. I know 2 to the -3rd is 1/8. So there's my answer, -3. Whichever way works for you. That's great. Just be ready to adjust and adapt. Rewrite that as 1/5 and you'll get it. Yeah, you're doing great.
Are these are not possible?
Yes, I like that. I like that. No! We'll say, what's that? -infinity? I like that. If this was 0 plus, I would say you were correct, but it's not. It is 0 on the dot. Yeah, or undefined. All right. 10 cubed is 1,000. The log of 10, log base 10 of 10 to the 3rd is the same as the log of 10 of 1,000. There's another way to get 3. Or you rewrite this as 10 to some power equals 1,000. I don't care. Just get the right answer. 16 square rooted is 4. So a 1/2 power would give me 4. A -1/2 power will give me 1/4. Now let's say you can't get that right off the bat. Well, maybe you write this as log base 16 of 16, and then you're thinking, oh, I got to flip it, and okay, there you go, there's a -1/2. Or maybe you rewrite this as 16 to some power equals 1/4. Whichever way makes the most sense to you. It's really, they're all the same. They're all equivalent. You just got to get -1/2. Now the next two are a little tricky, so quick little heads up. If you write this as a 1/5, you're good. It'll be easier to deal with. Maybe you can figure out right away what the answer is. Maybe you rewrite this 1/5 as a 5 to the negative first. Maybe you rewrite this as 5 to the power equals a 5th, and maybe one of those methods speaks to you, so you get -1 the answer. Did we just break a glass or those keys? Gosh. I'm trying to leave.
Really?
Listen, it's a beautiful day outside. Like, maybe I'll take 4th period. Maybe I'm going to skip 4th period. Do you think they'll call my mom if I skip 4th period? No, I think I can get away. All right. Maybe you root 3 to the power both sides to really understand what's going on, because it's weird to have a root in the base of a logarithm. Maybe you do that. Maybe you think about how you can write root 3 to a power to get 3. Maybe you just realize that root 3 squared is 3. Okay? We get to our next two, and we start with a half. I'm thinking about what power to a half gives me 16. Well, I know a half to the negative first makes it 2. I know 2 to the 4th is 16. So I need maybe a -4 there. I'm getting blown up. I want to make sure I'm okay.
Are you on your phone right now?
Hey, it's actually my mom. This is not a joke, guys. My mom is here. Hey, I was just like talking about how I might skip 4th period, and I'm like, but maybe somebody's gonna call my mom like I call your guys' mom when you skip. How's it going? Is everything okay?
How does this work?
I'm good. Is everything okay? I just answered to make sure you're okay. No, okay. Cool. Let me call you after school, and we'll talk, okay? That's a good message to send. Thank you. All right. That was weird. I have to admit. It was almost like a universal sign that I needed to call my mom. Yeah, that's what she said. She's like, you need to call me. I'm like, okay, all right. All right. So you need to know that the square root of a third is the square root of 1 over the square root of 3. So the power is a half. Maybe you rewrite this to figure this out. Yeah, this one's a tricky one. We get to the next two, guys, and everybody's like, I don't know what to do here. Well, you rewrite it if you don't know what to do. You figure out it's like 7 to what power is 0? What's 7 to the 0 power, Linder? 1. It is no solution because we know what 7 to the x looks like. 7 to the x, exponential function, multiplied by 7 over and over and over and over again. You start with 1, you get 7, 49, I don't know what it's after that. You get 1/7, 1/49, 1 whatever. You get smaller and smaller, approaching 0. You get larger and larger and larger. You never equal 0. You just approach 0. This is why, for log functions team, as you approach 0 from the right, your log function will approach negative infinity. It would not exist. If it was approaching 0 from the left, I'd say there's no graph there. It's undefined. Okay, so this can't happen. So there is no defined value for the log of 0. Because the y values of exponential functions are always positive, the x values you can plug into exponential functions can only be positive. It has to be bigger than 0. Going back to this one, I would maybe start as 1 over root 3 equals a third to what power? The square root of 1 over 3 is the square root of 1 over the square root of 3. So that's why it's a 1/2 power. Oh, in the future, we will find there's an easier way to do the last two. No. Here's what I would do. I would either rewrite it or figure out the power of 9. Now, watch this, guys. Whenever you see a 9 and an 8, bring it down to make it a 3. I'm immediately going to say log base 9 of 9 to the 1/3. Well, this is, 1/2. The square root of 9 is 3. Okay. I don't want the log base 9 of 3. I want the log base 9 of 27. So this isn't true. But I know that 3 cubed is 27. So I can think about 9 to the 1/2 to get 3, cubed to get 27. I get that the log base 9 of 9 to the 3/2 is the same as the log base 9 of 27. You can try to figure that out. 9 to what power equals 27, but it's really the same thing. Try getting it down to its simplest root and then taking that root to a power. So it's like I square root 9 and then cube it. So 3/2 power. Now I'll let you know a little secret. Next class, we will learn a different way to evaluate this. Very easily, we will be able to take the log base 3 of 27 divided by the log base 3 of 9. It's called change of bases. I can turn it into base 3 because, here we go, I'm going to pick on people randomly to help me out. Quick, G. Ford, what's the log base 3 of 27? Do you know this? Don't look at your paper, just look on the board. You're not with me, I know that. So, okay, what's the log base 3 of 27? Good, we got 3. And then, let's go on somebody randomly. T. Ford, okay, T. Ford, what's the log base 3 of 9? 2. Great, so there's another way to get 3/2. We will learn that next class, but for today's class, we're expecting you to be able to think about what is the power of 8 that gives you 4. I just said would. Next class, I'm going to teach you about change of bases, and that's how we get 3/2. 5% of my patients left. I still have some left. Next week, I'll lose 20%. It's okay.
What?
Listen, glad y'all laughed. Okay, everybody laughed means you're really understanding what's going on. We'll just let Linda sit with that, okay? What? Of AP pre-calculus, there's 3 units. Yes, and we're still in unit 1. Okay. Second semester. That's what I can't wait for. Yes, I'm great at teaching the unit circle, and maybe you'll learn something from me. So 8 to the 1/3 is 2. 2 squared is 4. 8 to the 2/3 is 4. The answer to this is 2/3. Okay. Now, guys, if you understand kind of this technique of rewriting it, the natural log shouldn't be scary. The log base e of e to a power is the power. Okay, log base 2 of 2 to a power is the power. Log base 3 of 3 to the power is the power. The log base e to the 7th. Let's start with this one. What's the natural log of e to the 7th?
7.
Yeah, 7. It's just 7. Okay? The log and the e undo each other. I would not rewrite this. It'd be silly for me to rewrite it because I understand logs and e's, logs and exponents undo each other. But what's the natural log of e? What's the natural log of 1? Maybe you don't know what either is, so you have your backup. Rewrite it. Maybe you're not sure what you're doing. You can always rewrite it. Come on, write down the answers right now to the log of 1 and log of 2. He didn't. And you didn't.
Jeez Louise.
You're on the wrong page.
Needless to say, I'm more upset than you are this semester. I can assure you that. I'm disappointed in my brother. G4. You're my lover. Hey, brother.
Broughton, we're doing it wrong here. Log base e of 1 is ln. Not log base 1 of 1. Log base e of 1. What is this? I'm not sure. Take e to the power. You have the equivalent. E to something is 1. If you're not sure, you can rewrite the statement using the inverse. E to what power is 1? Or you can rewrite 1 as e to the 0 to know that the natural log of 1 is 0. Either way works. What is the natural log of e? I wouldn't have to do anything. I wouldn't even want to rewrite it because there's a power of 1 right there. Logs and e's are, logs and exponents are inverses of each other, so we just get 1. Okay, so that means this must be 1 as well, because it's 1 over 1. Tell me what that answer is. Yes. Logs and e to the powers will undo each other. Let's say you didn't get that, and you're like, I didn't. What the heck just happened? Well, you can rewrite it. 1 over e equals e to what power? It's got to be -1. No, we got 2 more. Oh, and the last lesson is going to kick your butt, too. Really, really tough equations with logs and exponents that I can't wait. This is e to the -1/3. The natural log of e to -1/3 is -1/3. Okay. On your homework. You guys are all feeling good about yourself. You're all like, this is easy. Maybe I listen to Mr. Messner. Maybe I don't. Usually I don't. Sometimes I do. We go to question number 7, which actually kind of stumped me a little bit the first time I did it. And then I had the right idea, but I redid them for every single question. But this is like coming straight off of your test and coming straight off of your quiz, the question just like this. And this question usually stumps the students in here who on your notes just write the answers right away. The students who are always just like, oh, I know this means exponent, and you're like, oh, this one's 2, this one's 3, this is -0.5, this is -2, this is -5, that's 7, like, and you're getting the answers right there, you probably will have the most difficult students. And the people who are willing to adjust and adapt and to understand inverses will understand the different way to look at this question and will discover something that they can use to answer all 6 of these fairly quickly. And let's see if any of you can figure this out. Rory's on it. No, it's all about M. Now, the answer isn't just M all the time, but it's like expressions in terms of M. Is it like M over 2? Is it 2M? Is it M squared? Like, it's like the ideas like that. No, they're not right. The first one's right. Good job, Bang. Twan, you got it? No.
Can I go?
Could you rewrite this, please, using exponents instead of logs? Can you undo the log? You have the right idea, Linda. You just have the wrong execution. Like you got the right idea. No. You have the right idea. Trick it, you're off. Guys, ready? Here we go. Let me help you out here. If you are not sure when you see a log, get rid of the log. Now, it doesn't just disappear. You need to use the inverse. Take a different approach. Those who rewrite this as m equal b to the 12th have a chance to answer these questions. Now, many of you will be like, oh, b to the 12th is m. Great, you got the first one right. To answer all of the remaining questions, use this. B to the 6th. Well, I don't have b to the 6th. I have b to the 12th. But what can I do to this equation so it turns into b to the 6th? No. No. Yes. What is an exponent rule that you know that can change this exponent of 12 to an exponent of 6? We take both sides to the 1/2 power. This is like Woods, your question about don't roots undo, like no, but good. So what's your answer? Not a half, m to the 1/2. That's what I was saying, you were on the right track. You just didn't have the right execution. M to the 1/2 is equivalent to b to the 6th. No, you're wrong. What is this? What is that?
No, just be a negative m.
So m squared, you're saying? Like I want m. Yeah. Whoa, no.
I mean,
Yo, it's all gonna come back to m equals b to the 12th. What do I take the 12? No, you're wrong, Woods. How can you turn this 12 into a negative 12? No, Woods. Just stop. Yes, I can. How can you make this power a negative 12? Take both sides to the negative first power. So guess what? B to the negative 12 equals m to the negative first, and I'm going to write 1 over m because I don't like negative powers. So Roy, there's probably a conceptual way to get these answers, and it's like, so Sorry, I have b to the 12th equals m. I want b to the 24th. Yes, square both sides of the equation. Yeah, but I would use a 1/12 power. That's fine, you're good. Yeah, 1/12 power, yeah. So, Schweiri. Look, b to the 12th squared is b to the 24th. M squared, m squared. No, Schweiri, You kidding me? Sorry, what's x squared cubed? Is it x to the 8th? So what did you do with those powers? Because you just told me that you should go 2 cubed and you get 8. Because Babbitt's got it. Yeah, sure, that's it. B to the 12th equals m. I want b to the negative first. I will take both sides to the negative 1/12th power. Because powers to a power, you don't take 12 to the negative 1/12th power. X squared cubed is x to the 6th, not x to the 8th, right? We multiplied the powers together. So this is m to the negative 1/12. This is 1 over m to the 1/12. This is 1 over the 12th root of m. This is b to the 1/2. I start with b to the 12th equals m. Exponent rules, I would divide by 24. Because 12 divided by 24 equals 1/2. M to the 1/24. All right, just get out of here. I don't want to see you guys anymore. Anyways. All right, later. Yes, this is going to be on the quiz and on the test. Yep. Yes, on the quiz and on the test. It's on your homework, right?